Derivative of sine of x, or theta, or whatever you want to call your angle. The derivative of the sine function is equal to the cosine function times the derivative of whatever your angle here is. In other words, if I want to find the derivative of sine 4x, well, the derivative of sine of an angle is the cosine of that angle times the derivative of that angle giving us 4 times the cosine of 4x. And again, so many people forget that. They forget to then multiply by the derivative of whatever your angle is. Now, of course, if I just want the derivative of sine of x, I get the cosine of x times the derivative of x, but what is the derivative of x? It's 1. So if you look it up, they'll tell you that the derivative of sine is cosine. They don't say anything about the angle measure. You need to think about it. The derivative of cosine is negative sine of x times the derivative of x. If it's a co-function, the derivative will be negative. If it's not a co-function, then the derivative will be positive. That's one little thing that you can use to remember. So we haven't talked about cosecant or cotangent, but I guarantee you when we get to them here in just a few moments, those derivatives will have to be negative because they are co-functions. But sine, secant, tangent will have to be positive because they are not cotangent or co-functions. Example problem. I want to find the derivative of the sine of x divided by the cosine of x minus 2. Now you've got to realize you are looking at a quotient. You have to use the quotient rule. You have to use low d high minus high d low all over low squared. So your derivative is going to be equal to the cosine of x minus 2 times the derivative of the sine of x minus the sine of x times the derivative of the cosine of x minus 2 all over the cosine of x minus 2 quantity squared. Now, would you write that all down like that? Oh, probably not. I wouldn't think that you need to, but that's what you're thinking. Hopefully, you would simply write down, okay, in the numerator, I've got the cosine of x minus 2 times, well, the derivative of sine is cosine, minus the sine of x times negative sine of x plus 0 or minus 0. Simplifying, what do we got? We got cosine squared of x minus 2 cosine of x plus sine squared of x all over my denominator squared. Oh. What do you know about sine squared plus cosine squared?
1.
It's an identity. Can't forget those identities. So that gives me 1 minus 2 cosine of x all over cosine of x minus 2
That's the only one I
quantity squared. I guarantee you this would be a multiple choice question. So you can't stop here, because I promise you that would not be an answer choice. So what we have to do is remember how to simplify. If you were working a problem like this in the free response, shoot, you could have quit right there. But that's too easy, so we will challenge you a little bit on the AP exam. So we'll be sure if we have a problem such as this where we want you to apply your pre-cal skills, it'd have to be on a multiple choice question. And we would make sure not to give that as an answer choice. That would have to be your simplified answer. Got it? Moving on. Simple harmonic motion is a motion, well, an example of simple harmonic motion is you put a weight on a spring and you watch it bob up and down. That's simple harmonic motion. I've got a weight hanging from a spring and it's bobbing up and down, and the position function is 3 sine of t, where s is in meters and t is in seconds. We want to find the velocity and the acceleration with respect to time. This is not a particle motion problem, but we're still going to ask you about the velocity and the acceleration of the weight bobbing up and down. Nothing changes though. That's the beauty of it. We all know that velocity is the derivative of the position function. So I know that the velocity's got to be equal to 3 times the derivative of the sine of t. And of course, the derivative of sine is cosine. So we have 3 cosine of t times the derivative of t, which is 1. So there's my velocity. And my acceleration is equal to 3 times the derivative of the cosine of t, which gives me negative 3 cosine of t times the derivative of t. I'm going to share with you another topic, but it's not covered on the AP exam, but I just like it, so I just want you to know about it. It's called jerk. Jerk. A sudden change in acceleration is called jerk, J-E-R-K. A sudden change in acceleration is called jerk. When you ride in a car or a bus, it's jerky. It's not that the acceleration involved is necessarily large, but the changes in the acceleration are abrupt. Jerk is what spills your soft drink in the car. Recent tests have shown that the motion sickness comes from accelerations whose changes in magnitude or direction take us by surprise. Keeping an eye on a road helps us see the changes coming. A driver is less likely to become sick than the passenger who's reading their book in the back seat. The derivative responsible for jerk is the third derivative of the position function. the third derivative of the position function. The derivative of acceleration is called jerk. So we say that jerk J of t is the derivative of the acceleration function with respect to time, which is the third derivative of the position function with respect to time cubed. That's called jerk. I think that's kind of fun. Always wanted some of my classes to come up with a calc t-shirt that says, don't be that, take calculus, or something corny like that, you know. Don't be a jerk, take calculus, but that never flew, so whatever. Moving on. We've now got the derivatives for sine and cosine. Let's look at the other four. The derivative of tangent. We all know that tangent is sine over cosine. Therefore, if I take the cosine times cosine minus sine times negative sine all over cosine squared, I get cosine squared plus sine squared all over cosine squared. And you told me a moment ago that sine squared plus cosine squared is equal to 1. If you know your reciprocal functions, 1 over cosine is equivalent to what trig function? Secant. So 1 over cosine squared is secant squared. So the derivative of tangent of x is secant squared of x times the derivative of the angle. Derivative of tangent is secant squared. The derivative of cosecant is equal to negative cosecant x cotangent x times the derivative of x. Remember we was talking about cofunction a moment ago, and I said cofunction is going to be negative. The derivative of a cofunction is negative. Well, there it is. Negative cosecant times cotangent. The derivative of secant is equal to secant x tangent x times the derivative of x. And last but not least, the derivative of cotangent is equal to negative cosecant squared times the derivative of x. Again, here's another co-function, cotangent. Its derivative's got to be negative. If it's a co-function, cosine, cosecant, cotangent, that derivative, whatever it is, got to be negative. Got to be negative. So finally, let's go back to an earlier type of problem that we have already mastered. I want to find the equation of a line tangent to y equal x times the cosine of x at x equal 1. in order to write the equation of any line, we have to know the slope and we have to have a point that the line passes through. Well, I don't know either one. How do I find the slope of that curve? I differentiate it, right? So I have to find the derivative of x cosine of x. Please note you're looking at a product. X times the cosine of x. I have to use the product rule, where I have to take the first factor times the derivative of the second plus the second factor times the derivative of the first. And again, if you already know that particular differentiation rule for a product, you just cut to the chase. Derivative of cosine is negative sine, so I've got negative x sine of x, and cosine times derivative of x, which is 1, cosine times 1 is cosine. So there's my derivative. And I need to evaluate at x equal 1. So I've got negative 1 times the sine of 1 plus the cosine of 1. Never ever use degree measure. It's always got to be radians. So in radian mode, I need to find the sine of 1, multiply it by negative 1, then add to that the cosine of 1. And if you do it correctly, we come up with negative 0.8414709,848 plus 0.5403023059. Therefore, I say that my slope is equal to a negative 0.3011686789. There's the slope of my line. Could you math 8 that? Try it. Try it. Math 8. The derivative with respect to x of x cosine of x evaluated at x equal 1. Did you get what I have up here? I hope so.
Yeah.
You shoulda. At x equal 1, y is equal to 1 times the cosine of 1. So y turns out to be 0.5403023059. I rounded those numbers off. I mean, that's a pain in the patoot, writing that all out and everything. Why didn't I just round them?
Because it's not your final product.
Exact value.
Because I can't round them. You can't round any values until the final answer. So, for my equation, I'm going to take y minus the y coordinate of the point, which is right here, and now I can round it, equals my slope, which is negative 0.841 times x minus 1. The wrong slope, I looked at. How about negative 0.301? Now let me check my work. Yeah, that looks much better. Should I put it in slope-intercept form, y equal mx plus b? Oh, no, who wants to do that? That's just a waste of time. So, basically, we've got 6 new differentiation rules that you need to know. Everybody seems to do well with the derivative of sine, the derivative of cosine, because you'll work with those the most. A few tangents, but maybe once in a blue moon you'll come across, find the derivative of a cosecant or a secant or a cotangent, but you still have to know those. You still have to know those. Your homework assignment for Monday will be out of your book. We're now in lesson 3.